Well, it wouldn't make sense to use U-substitution to find antiderivatives unless we can compute definite integrals using U-substitution. So I have three examples on how to do that coming up, okay? I can do it two different ways. This should be a shorter video this time. We did a lot of work on U-substitution earlier on the previous video. Let's do the same thing again. All right, so this first one says the integral from 0 to 3, this guy right here, of dx over 5x plus 1. Now, sometimes you just want to help people along and go, listen, this is really the integral from 0 to 3 of 1 over 5x plus 1 dx like so. Okay? All right. I don't know how to integrate that. What do you do? Okay, you got to think about integrals, you know. In fact, you might go to page 403, maybe even have it near you, like a copy of the sheet and have it next to you while you're doing your problems. The one that this kind of looks like, if we can get it there, is the integral of like 1 over x dx. So that kind of gives me a hint. How about I try let u equal 5x plus 1? Then du is 5 dx. And so therefore dx itself is 1/5 du. Why is that a big deal? Well, I think we're getting somewhere. So what we have is this integral is integral 0 to 3, 1 over 5x plus 1, and then dx. But with this substitution, all of this becomes u, and dx becomes 1/5 du. So becomes a new integral. It's 1 over u times 1/5 times du. So what? Now, two things to notice. Everything's in terms of u, not x. And I didn't write the limits down this time because I don't want to get confused. I don't write the limits down when I change it to u. When I change it back to x, I bring the limits back. Okay? So, because if otherwise, here's the thing, do not use the x limits with u function. You'll get the wrong answer. The x limits belong to x. So I'll show you. What we have is this is a 1/5, get them out of the way, integral 1 over u du. Why did I see 1 over u du? What does it say on page 403? What have we learned so far? What we've learned is that is equal to the integral of 1 over u is the natural log of u. Actually, the natural log absolute of u, which has not been covered yet, I don't think. We should cover that in case it hasn't been, and then plus c. Okay, now here's the thing. It's a definite integral, so I'm actually not going to put plus c there. I'm going to put limits, but I'm going to leave it alone. And now I'm going to bring x back. It's equal to 1/5 the natural log of, what is it, 5x plus 1, absolute value, 5x plus 1, from, now the limits are used, from 0 to 3. Okay? And we apply them. So we have 1/5, and in the bracket we have the natural log absolute of 3 times 5 is 15 plus 1 is 16. Okay. And then minus the natural log. Yeah, we do that. And it's 0 plus 1 or just 1. In a previous example, we found that the natural log, of course, of 1 is 0. We're getting an answer of the natural log of 16, 1/5 of that, as a final answer. So what? Well, it's the same thing, isn't it? You have to u sub, you integrate with u, you put x back, and then you apply the limits. Okay, pretty basic stuff. Okay, let's do a couple more. This one's pretty straightforward too. You ready? Okay, this one, I don't know how clear it is to you, but it would be nice if this were just e to the u, right? That would be nice. If I had to integrate e to the u du, that's what it's reminding me of. So therefore, it's letting me think, well, let u equal minus x squared, then du is equal to minus 2x dx. And look what we have. Remember x dx? We've seen this before, haven't we? So therefore, x dx by its lonesome is minus 1/2 of du. So see how this keeps on iterating? It's integral from 0 to 1 of x. In fact, I'll write this a different way. I'll write it as e to the minus x squared times x times dx. Okay, so we can see this better. And what we're seeing is this guy, the power will be replaced with u. We did that on purpose. And when we did that substitution, the x dx is going to turn into minus 1/2 du. So let's do that. We have integral, no limits. It's e to the u times a minus 1/2 times du. Without blinking, what I do is I move that minus 1/2 out of the way, okay? And I've got integral of e to the u du. Bless you, I know that guy. It's minus 1/2 e to the u again. But now I'm going to change it back to x. It's minus 1/2 e to the minus x squared. And now we apply the limits 0 to 1. So we have minus 1/2, and then in here we have e to the negative 1 squared minus e to the negative 0 squared, which is silly, because really what we're getting is a negative 1/2. In here we have 1 over e, and then minus 1. Okay? You could say this a different way. You could say something like it's equal to maybe 1 minus 1 over e over 2. The two negatives cancel each other out. I can turn it around and bring out a negative. Okay, so that's an answer as well. Okay. So one of the lessons that you can do in this case, though, watch this, is if you get to the u guy right here and you don't put limits in, and I did this on a previous example, I think I did it on the previous video, is you can change, I'll say, but you can change the limits. You can change the x limits into u limits. Okay, how do you do that? Well, it's up here. Let's do this example. I did it before, I'll do it again. Here's x and here's u. Back to the previous example where u is 5x plus 1. Okay, and the limits are 0 to 3. For x, I can see them right there. Now, I plug in 0 and I get 1 for u. I plug in 3, I get 16 for u. And you can change these limits to 1 to 16, and some of the math is done. So that you could actually apply the limits 1 to 16 here, 1 to 16 here, and then jump out and go, my answer is minus 1/5, natural log of 16, minus natural log of 1, okay, he's gone, and get the right answer. So, changing the limits. A lot of people don't do it. You don't have to. You can put everything back in terms of x if it's too confusing. I do see an advantage, like sometimes when I've changed the limits and it became the u limits up here could have been like 3 and then 3 again. I don't have to do any more work because I know the integral is 0. That can happen on, say, an even function or something like that. Or no, an odd function, okay? Or when I'm doing next semester, you're doing like a trig substitution and getting back to x is a pain in the butt sometimes. You can convert to theta limits and then it's a little bit easier. But if you don't want to learn that skill, you don't have to. If we did it for this one, we'd have, okay, so here's x and here's u, and we let u equal minus x squared. Remember this guy, okay? We used that one before, now this one. Well, in this case, the limits are 0 to 1. It's easy enough to plug in 0, and you got 0. Plug in 1, you get, what do you get? A negative 1, right? And so your limits on this could become, oh, for u, it could be like 0 to negative 1, and then go from there. I've got one more to show you. This one's important to show you because this is where you just get downright tricky. Okay, so this is the last one on this video. I do believe, yeah, it is. It's a good one. Here he is, right here, all nestled in amongst all this beautiful calculus work, right? What do you think the U should be on this one, just goofing around with it? If you do enough of this homework, you go, I think most people's instincts are good on this. They go, well, let U equal 1 plus 2x. Maybe that'll work. Okay. Then du is 2x dx, I think. Okay, what do we have outside the radical? Because if this is going to be, oh yeah, there he is. No, I got it wrong. No, I'm going crazy. I'm getting tired. What are you doing, Weber? It's just 2 times dx, isn't it? What's outside? Oh, trouble, right? This will make people stop. They'll go, okay, I don't know what I'm supposed to do here. I'll show you. Ready? Okay. So let's rewrite it and see what we have to do. We have this integral, 0 to 4. We've got, let's do it this way, 1 over the square root of 1 plus 2x. Check. This is going to be replaced with u. We're going to be good shape there, okay? In fact, if I anticipate it, I'll go down here and go, okay, it's the integral. Forget the limits for now. I'll just say it's 1 over square root of u so far, okay? But also in this integral, there's an x, and also there's a dx. Well, dx is not hard. Dx I can find right here, like we've done before. So therefore, dx is equal to 1/2 du. So this guy's going to be replaced with 1/2 times du. Great. So we have a 1/2 involved and a du. Lovely, like all the times before. Here's the thing. I'll put this in a different color. Okay, let's make it blue or something. Here's the trouble right there. X. What the heck is x? What do I do with that guy? Usually it's good to go back to your original U substitution and go, is there any way I can figure out what x is? Like for instance, u is equal to 1 plus 2x. Help. Well, u minus 1 on a rainy day, you might dawdle around and do this. Oh, wait a second. Are you kidding? We have 1/2 u minus 1 is the same as x. Am I supposed to do that? You know what? Yeah, it's a great idea. Because look, I'm going to go times 1/2. I'm going to do that. And then times u minus 1. Oh, come on. We can't do that, can we? Yeah, we can. Watch. We're getting, let's see. I'm going to take the 1/2s out as 1/4 if you're okay with that. They both come out. And we have an integral. And upstairs is u minus 1 and downstairs is square root of u. Some of you might think we're still trapped, but some others are going, are you kidding? Oh my gosh, you can do that. Yes, you can, because you can go 1/4 integral u over the square root of u. Oh my gosh, I hate calculus. Yeah, no, you don't. You love it. 1 over the square root of u du. Okay. And you can see where this is going, can't you? We've done one like this before, at least one. So this is really u, I'll cut to the chase, u to the 1/2 power minus u to the minus 1/2 power, like so. Keep going. It's almost done. It's 1/4. And let's see, u to the 3/2, it's going to be 2/3 u to the 3/2 power. And then minus the u to the 1/2 over 1/2 is minus 2 u to the 1/2 power. Okay. And we integrated it. Yes, we can put u back, but you know what x back, but what I'm going to do instead is I'm going to do that little change of variable. U is equal to 1 plus 2x. The limits of integration for x are 0 to 4. The limits for u, 0, 1 plus 2 times 0 is 1. 1 plus 2 times 4 is 9. So 1 to 9, I'm going to switch the u limits also. Yeah, it's a thing. And let's see what we get. This is the final answer. We just have to grunge through the numbers now. This is going to be 2/3 times 9 square rooted is 3 cubed is 27. 27 minus 9 square rooted is 3, so minus 6. Now look out, we're plugging in a 1 now. And here we get 2/3, no matter what 1 is. Whatever power it is, you just get this number, and then minus 2. So if we can figure this out, oh boy, we don't have any room. We can get the answer. So it's 1/4. What do we have? That's going to be 9. That's 18 minus 6 is 12. Minus 2/3. Minus a minus is plus 2. So let's work down here, I guess. We got the answers coming at you, man. This is the longest part for me. 14. It's really 14 minus 2/3. Okay, so that's, okay, 30, 42 minus 2 is 40 thirds, 10 thirds. I think the final answer to that guy's 10 thirds. Okay, that's enough on that. You guys go ahead and go crazy on the homework there. A lot of practice there will make close to perfect. We'll see you next chapter.